You're just going to write the 8 identities and then I'll grade it. Now, the 4th block class, what they're going to have to do different is they're going to have to write the 8 identities on a blank sheet of paper and turn it in to Mr. Sanders, and then they get their test. So that way I make sure they haven't looked at their notes to write down the 8 identities. Does everybody follow what I'm saying?
Yeah.
Okay. Now, once you get your 8 identities completed, then you can use your calculators and your trig information sheet. The first 2 things you're going to do is 2 that are going to be simplify a trig. That means write it to a single trig expression. Remember doing that good stuff? 2, verify a trig. What's verify mean?
Get one side and do the other side.
Make one side look like the other. 3, we're going to use exact values using the sum and difference. So that means you're going to use the sine of A plus B, that formula. And you're going to make use of the numbers up here to come up with the combination. Remember, everybody can use different numbers to come up with those values. Then there's going to be, now notice this says 1, but it's 1 where you're going to set up a triangle, and you're going to use that triangle to answer, I think, 3 questions here. So there's going to be 3 questions on this one. And this one, another one, you're going to do 1 triangle, you're going to set up triangles. Well, this one you're setting up 2 triangles. This one you're setting up 1 triangle only, and you're going to answer 6 questions. Double angles. So there's going to be a sine, a cosine, and a tangent of double angle, and then there's going to be sine and cosine and tangent of half angle. So this is going to have 6 questions. And then, what have we been doing so much of? Solve. So, there are going to be a variety. Some of them are going to be simple. Some are going to use, we use the quadratic formula. Some require factoring, and what else could be involved? Fractions. What else? Where you got to get it in terms of the same trig. And what about double angles? That's a possibility too.
Are you going to have any triple angles?
No, I'm not. Okay. So is everybody ready to go? Has everybody got that down, or we?
I think so. I have one more.
Okay. If you would, I think, let me see, in your book, we're going to throw problems out. Normally, I think Mrs. Schenker always has you do a review practice problem pages or something before the test. I'm not going to. We're just going to use them as examples. Yes?
For identities, do we have to write like?
No, you just have to know one of them.
Okay.
And it doesn't matter to me which one.
Okay.
Let me make sure we're on the right page where the review is. What page was our last assignment in the book? 567. No, am I looking at the right one? Nope. Yeah, it is 4-7. Algebra 2 is the one I just got finished grading, so that's it. 459. So 459. A little bit past that. I'm in the chapter, it's 478, so look in that group. Well, that's where the ACT is. I guess it starts on 478.
Page 478?
Yes, I see the verify right there. Okay, is everybody see where I'm at?
478.
I'm just going to use those as examples. Instead of having you assigned to do them, we're going to use them as practice problems. So on page 478, number 15.
Okay.
So this would be example of simplify to a single trig. So it's cosecant of x minus cosine squared times cosecant of x.
Make them signs and pencils.
You could do that. I see something I like better, Becky.
Take out cosecant.
Factor out a cosecant. What is 1 minus cosine squared?
Sine squared.
And now remember, you will have your, after your 8 identities have been graded, then you can use your trig information sheet. So that means if you made a mistake, even though I'll count it wrong on the 8 identities, you'd be using the correct ones when you're doing the problems. So this would change to And that would be a single trig. Okay, is everybody good there?
Just 1 second.
Then we're gonna look in the verify section, which
Is
16 through 19, you guys look there and see which looks good. 18?
I know, I was thinking that was good. Sweet.
Yeah, probably.
18, okay?
You
Let me
can just
see.
cross multiply.
Ooh, I like 17 the best, but that's
Let's
okay.
do 17
Yeah, it's a
then.
17.
Because you got a foil. You guys have done factoring. Oh, but this one has butterflies, so would you rather practice a butterfly?
Can we do one of each?
We could. So we're gonna start with 18 or 17?
17.
I think we gotta go in order.
One order.
Which one? 18. Yeah.
So 17 is 1 minus cosine, and I'm just gonna change to x over 1 plus cosine equals,
Parentheses cosecant of x minus cotangent of x, parentheses squared.
quantity squared?
Yeah.
Okay, which side do we want to work with?
Squared.
The square side?
Yeah.
Now, do you want to change what's inside the parentheses first?
No.
No.
Boil it out. Maybe.
I mean, could we change, and then like,
That's what I would do. I'd change what's inside first,
Yeah.
Then let's do that.
Why?
because then I'd butterfly once, and then have the answer to multiply times.
have it squared.
So this would be 1 over sine
Yeah.
minus cosine over sine. Oh, I don't even need to butterfly.
Yeah.
Yes.
So what do we get?
1 minus sine. 1 minus cosine over sine. There we go.
Now, if you square that, that means you take it times its,
So.
so we get sine squared.
You gonna say this?
Yes, sir.
Could you slow it down a little bit?
Plus cosine squared? No.
I don't think if you guys write as fast as I do. You comprehend it, yeah. So 1 minus cosine times 1 minus cosine, don't we have to FOIL that?
One minus cosine minus.
They're all over the same denominator, Mason, so
Right.
we just wrote it that way. And since
Oh.
it's quantity squared, we had to write it twice. And now, we've multiplied sine times sine, which is sine squared. Then on top, you gotta do FOIL. So 1 times 1 is, the outer, the inner would be a negative 2 cosine. And last times last would be cosine squared. Oh, I don't even wanna do that. I forgot.
Yeah,
What did I
sine-
forget about verify?
Sine squared.
What's verify?
I think it looks-
Simplify, I just keep on going until I get to one. I wanna make it look like this side. I should've stopped. Cause this is sine squared. What's sine squared changed to?
1 minus cosine.
You see guys what I'm thinking?
Yeah.
I looked over here to see what I wanted.
So cancel.
So
Did you-
sine squared changes to what?
Wait, what did you do?
I didn't do anything. I just wrote that twice,
1 minus
Right.
cosine.
and sine times sine is sine squared.
Uh-huh.
Sine squared changes to 1 minus cosine squared, it's one of your 8 identities.
And then pick up the squares.
That's the difference of squares, I heard somebody say, so that would be,
1 plus cosine, 1 minus cosine.
right.
And then
And the squares cancel.
Then this cancels one of those, right?
Plus cosine, yeah.
That'll cancel one of those, so you'd be left with 1 minus cosine over 1 plus cosine. So remember to stop. Well, you know, a lot of times I get in a hurry just to, I wanna get it to the simplest form, and we weren't doing that on verify. Verify, you wanna make it look like the other side. Yes?
Okay, so whenever we change sine squared to the identity,
Mhm.
why is it 1 minus cosine? Oh, did you just break it apart?
Yes, I just factored it.
Okay.
Okay. The step right before the last one, you have the 1 minus cosine squared of x over 1 minus cosine squared of x.
which this factors to one minus cosine, one plus cosine. So then this cancels one of these out, because there's two of them up above, and that leaves just one up above, and then one plus cosine on the bottom. Okay, we good there? I'll move 18 up here. So while you're getting that one, 18 is secant plus 1. Over tangent of x?
Yeah, which equals tangent of x over secant of x.
You guys make sure I pay attention, we're only trying to make it look like the other side. Although I see something I could do to make it easy, or I could subtract it and make it equal to 0.
Yeah.
Then I would work even just with simplifying. To me, I like to simplify better than I do to verify. So that would be an option, isn't, because then that an equation?
Yeah.
An equation you can manipulate before you get started. Okay, so do you guys want to verify it as it is, or you want to make it where it's equal to 0? Equal to 0, because then we get to practice butterfly a couple times.
Yeah, let's do that.
Okay, so my first question is, do you want to butterfly as it is, or do you want to change the sines and cosines first? Butterfly as it is? So, oh, that's not too bad. Secant of x plus 1 times secant of x minus 1.
Secant squared minus 1.
And the second link would be minus tangent squared over tangent times secant of x minus 1. Now, hopefully you're looking at your identities.
That's tangent squared. Or, right?
Which one?
The secant squared minus 1. That's 1.
Secant squared minus 1 is tangent squared, correct? So tangent squared minus tangent squared is
0.
0.
Whoa.
So actually, I think that one was faster, to set it equal to 0. Okay?
So when we're verifying, we can make it look like this 0.
You
that
can
we
get it equal to 0. We could have done this one equal to 0 if we wanted to.
And then
That one might have been a little bit more,
Is that easier
Longer.
to do?
not always.
Not always?
In this case, it probably wouldn't have been, because you'd have had this quantity squared moved over there with that too. But that is an option, yes.
Okay.
Okay, so verify. One of my verifies is a good one of them's straightforward. Nobody should miss it. Like if I said tangent, if I said verify, what if I gave you this one?
tangent times cosine sine.
Tangent is sine over cosine. So one is straightforward, and one you might have to do the butterfly with or foil. Okay? Next, exact using sum or difference. Let's see. See if there's one in the book that's similar. Yeah. Oh, they're half angles on the top of page 479. Here we are. 20 cosine of 195. So this is an example of this one right here, okay? So this is where you make use of this. Which of those would you add or subtract to get 195? There's a lot of choices. Those up above, the ones that you've already got established on your thing, which of these would you add or subtract to get 195? Those right down there on yours.
Oh, okay.
225 and 30, there's one way.
150 plus 45.
150 plus 45. Remember I said everybody in here could do it a different way?
Yeah.
And it doesn't matter as long as you're careful with your math.
135 plus 60?
135 plus 60. We could keep on listing them, couldn't we?
Yeah.
Okay, which one do we want to pick?
150 and 45.
150 and 45. Now, what's the formula for cosine of A plus B? Cosine of the first, cosine of the second.
Minus sine of the first, sine of the second.
So that you're getting straight from the bottom of your page where the sum formulas are for the A and B. So A is what?
150.
150. B then is 45. Now, you go to your chart again. Where's the cosine of 150? No, what is the value of the cosine of 150?
Square root of 302.
Now, remember this is in the second quadrant, so that's the only thing you might, where people will make a mistake is they don't put the correct positive or negative on it. So you told me the sine, or cosine of 150 was?
Wait. How do we know what square root of
That's
302?
right.
Oh, yeah.
What's the cosine of 150?
Cosine of 150 is square root of 302.
And it's in the second quadrant, so isn't the cosine negative?
Yes.
Okay. What's the cosine of 45?
Cosine of 25 is the square root of 2.
What's the sine of 150?
Sine of 150 is 1/2.
Second quadrant, sine's positive, so I don't need to do anything. And the sine of 45? So negative square root of 6 over 4 minus square root of 2 over 4. Now remember, there's not any reason to miss these because what can you do? Check. Somebody find what the cosine of 195 is. And somebody else put in your calculator and find out what the negative square root of 6 is minus the square root of 2, hit equal, and divide it by 4. Who's got 195? Cosine of 195, what'd you get?
Negative 0.965.
Okay, so it's 0.96 negative? Okay, anybody have this done?
Yeah,
Negative square root of 6 minus square root of 2?
same thing.
Same thing. So it should be the same thing. So this group right here, there's no reason for you to miss them. You should check your answers to make sure it matches. Okay? You guys want another example there?
Yes, please.
Well, let's just go ahead and do, what if I want the sine of 195? So can I use one of these again? Why don't we use this one for a different one for 135? So the formula for sine of A plus B is sine of the first one, cosine of the second one,
And then sine of
plus sine of the second one, cosine of the first one, and our A is 135 and our B is 60. And this one's just another one, you guys don't need to write it down, it's just giving you another example. Now, we got second quadrant again, don't we? So that means you have to worry about positive or negatives in the second quadrant. What's the sine of 135?
Sine of 135 is square root of 2.
And it's in second quadrant, so sine's positive. What's the cosine of 60? And it's first quadrant, so I don't have to worry about it. What's the sine of 60? And cosine of 135,
Square root of 2 over 2.
but it's second quadrant and cosine is negative, so I get the square root of 2 minus the square root of 6, and I'm just going to go ahead and put it all over 4 since we know that the denominator's the same. Okay, so double check, what's the sine of 195, somebody, and somebody else take the square root of 2 minus the square root of 6, hit equal and divide it by 4. Is it the same?
What's that?
Did you get the same? Sine of 195,
Yeah.
and then square root of 2 minus the square root of 6 equal and divide by 4. Did you guys agree?
Yes.
Is everybody good there? What if I ask you to find the tangent of 195?
Take negative square root of 6.
Could I just divide these two answers?
Yeah.
So if I divided
Dividing
them,
the reciprocal.
yeah, you'd have to multiply by the conjugate, right? I mean, at eventually. I see what you're saying, invert and multiply. So this cancels. You got a negative square root of 6 minus the square root of 2 over square root of 2 minus the square root of 6, so then what would you have to do? By the conjugate, which is the square root of 2 plus the square root of 6. The bottom's easy, because it's first times first, last times last. On the top, you're gonna have to use FOIL. Get the room to do that, so that would be negative radical 6, or radical 12, for first times first. Outer would be a negative 6, inner would be a negative 2. Last times last would be a positive, oh, negative, sorry. Radical 12. And radical 12 doesn't simplify to 2 radical 3. So we're gonna end up with a negative 4 square roots of 3 minus 8 over a negative 4. And then everything you can divide by negative 4. So it's gonna be square root of 3 plus 2. No, negative divided by negative would be the positive. And then tangent of 195, somebody find that. And that's 2 plus 1.7, so that'd be about 3.7. Is that what you get?
0.26.
Okay, does everybody follow what we did? You need more examples of this group.
Well, those are different.
Are they different?
I think so. So let's put them on.
2 plus a radical 3 is is 3.7 approximately.
And 195 is 0.26.
0.26?
Yeah.
Yeah.
Oh, then something is wrong. Did I write it down right from the,
Maybe our signs on the first
Did-
one.
is
We
this-
got a negative.
is this what this, I see this one's right. What was the sign?
Square root of 2 minus square root of 6 over 4.
Square root of 2 minus the square root of 6?
Over 4.
Okay, so I have that right. This was, oh, I put the wrong over the wrong. Sine divided by cosine.
You just find.
Sine would have been what? I just,
Square root of 2.
you guys are gonna have to tell me what it was, because I don't have it
Square root of
written.
2 minus square root of 6 over 4.
Square root of 2 minus the square root of 6 over 4 times 4 inverting. Is that right now? 4's cancel?
Mm-hmm.
Okay, so we got it flipped.
Yeah, we had it flipped. So it'd be radical 6 plus the square root of 2. Let me get rid of this then. So on the bottom is the easy one. Negative times negative would be positive 6 minus 2. On the top, what will we get?
So you just multiply it by
The conjugate.
the top and the bottom.
By the conjugate. So
By
this
the
would be
conjugate.
2.
Wait, what about the conjugate? I don't understand that word.
Conjugate is where you just change the sign of the one in the middle. And
Okay.
you multiply the top and the bottom by it. That's how you get rid of radicals and denominators that have addition and subtraction involved.
Okay.
So I end up with 8 minus 4 square roots of 3 over 4. Does that look better? Does anybody remember what the tangent of 195 was?
0.26.
And that's 2 minus 1.7, so that's it. Okay, so make sure you put the sign over the cosine.
What we originally had too, square root of 3 plus 2, if we put a 1 over all that.
Yeah, we could invert it or answer. Yeah, that would work too. Okay, set up using exact values, sum and difference. So that means we're gonna set up a triangle. I'll just make up a problem for it. Let's say that we've got the sine of A equals 3/5, and it's in the first quadrant. Cosine of B is 12/13, and it's negative, and it's in the third quadrant. I want you to find the sine of A plus B. So I could ask you to find the sine of a plus b, I could ask you to find the sine of a minus b, the cosine of a plus b, the cosine of a minus b, the tangent of a plus b, or the tangent of a minus b. So you have 3 questions you're gonna get in here, so it could be any of those 6 I just listed. Does everybody follow what I'm saying there?
Yeah.
Okay, now, what's the triangle setup for this first one?
Sine is opposite over hypotenuse, 3, 5, 4.
So this is a 1 triangle. First quadrant. What's the cosine? Adjacent over hypotenuse. It's a 3rd quadrant triangle. And so Pythagorean theorem would be 12 squared plus something squared equals 13
And we
squared.
don't put the negative.
So it'd be 169 minus 144, so it'd be 25.
You're right.
Are we good?
I think so. So what is the negative effect? Is that just effect?
That affects it when you put it into the formula down here.
Okay.
Now, what is the formula for sine of a plus b?
Please release the baseball team at this time. And also softball has been canceled for tonight, but you will have practice at the old middle school gym. And before you leave today, I need Brody Mance, Caitlin Rodenbaugh, Shaylin Phillips, Shelby McCready, and Kobe Ewing.
Okay, so you guys know what's gonna be on the rest of the test, right? Okay. Sine of a, what is it?
Sine of a, that's 3 over 5.
Cosine of b, what's that? Sine of b, be careful.
5 over 13.
Negative.
Negative.
Why is it negative? Because
What quadrant are we in?
and sine is negative in the 3rd quadrant.
That is
that's why
correct.
it's negative.
And we didn't have to change the sign on the negative 12 or 13 one.
Because that's what it is.
And for the
Cosine
cosine,
of a is,
it's in the 3rd quadrant, so we don't have to worry about it, so it is 4 over 5.
right. Then all it is math. Negative 36 over 65 plus negative 20 over 65.
Yeah.
So negative 56 over 65.
Yep, sounds good to me.
Okay, do you guys want another one there?
No.
Okay, we're gonna do the same thing on this. Because we're gonna set up a triangle, but then it's gonna be double and half angles. Okay? I'll give us a different triangle though, so we practice setting up another triangle.
Okay.
Okay, are you guys ready for that, or are you still writing that one?
Alright, I think we're ready.
Good? Well, this time I'll use x. Let's say I give you the tangent of x. What quadrant do you want it to be in?
4.
Fourth. We didn't do one in the fourth, that makes sense. Is a negative, because that's what the tangent is in the 4th quadrant. Well, let's make it 4/3. So what's tangent?
And on these we only have one triangle?
Yes,
This is opposite of.
so that means this would be 5, right?
Yep. Yep.
Now, there's 6 questions, that means you're gonna be doing all 6. Sum, or you're gonna do the, not sum, the double angle for sine, cosine, and tangent, the half angle for sine, cosine, and tangent. So what is the sign of a double angle formula?
Sine of a double angle formula is 2
It's
sine.
2 sines times cosine.
So 2 times. What's the sign?
Sine 4 over 5. And it's negative.
Good. What's the cosine? And is it positive or negative?
5, and it is positive.
Positive. Because 4th quadrant cosine is positive. So our answer ends up being a negative 24 over 25. What's the cosine of a double angle? There's 3 to choose from. It does not matter which one you pick.
Let's do 1 minus 2 sine squared of X. What?
You must like that one. So what sign?
Sine is negative what?
And we've got a square, don't we?
Yeah, so 60.
And then you multiply by 2.
Seven.
Negative.
Seven.
Does everybody agree there?
Hold on. Seven
Does everybody agree with negative 7 over 25? Did somebody try a different formula? Like cosine squared minus sine squared? Could you have?
Yeah.
Yeah, you could have got the same thing. That could be something you could do if you wanted to convince yourself you're right.
How did they derive these, like these different ones?
Let's say we start with the first one. Cosine squared minus sine squared. Don't we have an 8 identity that says cosine squared is 1 minus sine squared?
Mm-hmm.
Yeah. So that's just 1 negative 1 minus 2. Oh!
That's all it is. It's making use of the 8 identities.
Tangent of 2x.
Do you see what I'm saying there?
Yeah.
Okay. Tangent of a double angle. Do I have to do the formula?
No,
No, but be careful. Make sure you put sine over cosine.
Yeah.
I always like to write my sine first, and that last time we didn't. So we have what? Negative 24 25ths times 25 over 7.
Cancel 25.
So we get a positive 24/7.
Yep.
I think we're good here, so I can go ahead and get rid of this, can I?
Yeah. And then we're gonna do the
Half angles.
half angles.
Oh, I better start with sine first. Otherwise I'll mess up my tangent.
If I go tangent.
What's the formula for sine of a half angle?
Positive negative square root of 1 minus cosine over 2.
Okay, so we just put our information in.
Cosine.
What's the cosine of this angle?
3 over 5.
3/5.
And
What's 1 minus 3/5?
does it like sign matter or?
It does, but in the fourth quadrant the cosine is positive, so it doesn't matter.
Okay.
So 1 minus 3/5 is,
2/5.
and then times 1/2, right?
Yeah.
Because this means divided by 2, and divided by 2 is times 1/2. So what does that become?
That becomes a third.
So what do I get, square root of 5 over 5? Now, here's the part you gotta think about.
Positive.
Is it positive or negative? What is the angle originally in the fourth quadrant?
Negative.
Think about what the largest one it could be. What's the largest one it could be in the fourth quadrant?
Wait, what?
What's the largest angle you could have in the fourth quadrant?
360.
359, because 360 is the axis, right? So what's 359 divided by 2? Because that would be half of it. Just take the largest and it works for all the rest of them.
359 divided by 2 is 179.5.
So what is the sine of 170, of that 179? That puts it in the second quadrant, doesn't it?
Do we just press sign or do we press second sign?
No, all you gotta do is tell me the sign, S-I-G-N.
Oh, okay.
Is it positive or negative? A sine of 179, is it positive or negative? It's positive because it's in the second quadrant.
Oh, yeah, okay.
So this is a positive answer.
I'm gonna confuse on that one.
Whatever quadrant you're in, you take half of it.
Okay.
That puts you into the quadrant you're gonna land up
So if
in.
I was in the first quadrant, I would.
You wouldn't have to worry about it, because half the
All of
large.
them are
So
positive.
if I was in the second quadrant, I would take 179.
Uh-huh, so that would put you at 89, so that'd put you in the first
So
quadrant,
that'd be positive.
so it'd be positive.
Okay.
Okay, half angle cosine is 1 plus the cosine over 2. So that would be 1 plus 3/5 over 2. So 1 plus 3/5 is 8/5. So I get what? So the square root of 4 is 2.
2 square root of 5 over 5.
Right, 2 square roots of 5 over 5. Now is this positive or negative? Remember the same angle you just did. Put us at 179, it's in the second quadrant, right? So cosine is what in the second quadrant? Negative.
Mr. Davis, I
Yes.
need some help.
What?
The homework from yesterday, I need some help on.
Okay, after we get finished reviewing.
Okay.
Tangent, how do you get tangent?
You divide.
Divide the first.
I put the right one on top, didn't I? Is everybody good there?
I'm still a little bit, how did we start out on them again?
There's the formula
Right.
for half angle. What you gotta find is the cosine of the angle, which comes from the triangle.
Uh-huh,
So cosine is 3/5.
right.
So then what's 1 minus 3/5? It's 2/5.
Mm-hmm.
2/5 divided by 2 ends up being 1/5. Take the square root of it, you get the square root of 5 over 5. Okay? Then, we knew that the largest angle you could have was 359. When you take half of it, it puts you in the second quadrant, which means the sign is positive in the second quadrant. Which down here, I knew the cosine would be negative. You could kind of do that at the same time. Then this one is plus. So you still use the same angle from that, which was 3/5. So 1 plus 3/5 is 8/5. 8/5 divided by 2 means you multiply by 1/2. So you get 4/5. You square root both the top and the bottom. Multiply by your radical and you got your answer. And then tangent is just invert and multiply.
Right.
Okay, are we good then?
Yeah.
Then what's left?
The 8 to solve.
Solve. Okay, so Dalton, pick a problem there that you're having problems with and we'll use it as our example.
Number 3.
Just read it.
1 divided by tangent of x plus 1/2 is equal to 5 over 16 plus 1 over 3.
Plus 1 over 3?
Yes.
Okay, with fractions, and you did this when you had college algebra, your first chapter. You also did it in algebra 2 in your first chapter, and you also did it in algebra 1 in about the 5th chapter. Anytime you have equations with fractions, you multiply by the common denominator. So what's the common denominator?
6 tangent of x.
6 tangent of x. So each term gets multiplied by 6 tangent of x. So the tangents cancel, I get 6. 2 cancels 6 to 3, so I get 3 tangent. 6 tangent cancel, I get 5. And 3 cancels 6 to 2. Now what do we do to get the tangent by itself? Subtract 2 tangent.
Yeah.
So it's gonna give me tangent. So where is what's the reference angle for tangent of 1? You can either use your calculator or you can, I think that one's on the chart.
Tangent of -1 is
What quadrants?
It's
45.
But what quadrants is tangent negative at?
Second.
Second and fourth, so to place the 45 in the second, it's 180 minus it.
Mhm.
To place it in the fourth, it's 360 minus it. And that's,
Okay.
so if you have fractions, which, is that a possibility for on the test?
Yep.
Yep. You multiply by the common denominator to get it by itself. Here, let's do another example. I don't know if you're to this page yet, Dalton, but what if I were to have 3 tangent squared minus 5 equals 4? What would I do to solve that? Add 5, divide by 3, but what's most important?
Plus or minus?
There we we go, I heard it. Now you gotta find the reference angle, I don't think this is on your chart. Is it?
Yeah,
Oh, is it?
60.
Oh, that's radical 3, yes. So reference angle would be 60,
Mhm.
so where's the tangent positive?
First and third.
First and third.
and then
Where's it
second,
negative?
makes it over.
So it'd be 60,
That's the tension of the
240, 120,
No.
and 300.
Oh, I didn't.
Are you guys okay there?
I like solving problems, it's so fun. So easy.
Okay, what if I gave you, yes,
For the tangent, and, I didn't get the rest of it, but it was the radical 5 over negative 2 times our radical 5, would the radicals just cancel?
mhm,
Okay.
mhm. What would I do on that one?
Oh, I know. Change.
Say it louder, Mason.
Yeah, change sine of 2x to sine of 2 sine of 2 sine times cosine.
Right.
Take out cosine.
Factor out a cosine?
Yeah.
2 sine plus 1. And so it'll be 1
So that one should be directed on your chart.
0 to 270.
90 and 270.
0 to 270.
90 and 270.
90 to 270.
Look where cosine is 0.
Okay, yeah.
And sine
Okay.
of x equals negative 1 half.
Whoa,
Reference angle is what, 30?
Yep.
And where's sine negative? So 30 plus 180 is 210. 360 minus 30 is 330. Okay, so we've done a factor, we've done a formula, we did a square root, quadratic. Can you read that to 2? So it's already equal to 0. Over 6. Oh, 64. So cosine is going to equal 2 plus 8 over 6. So what is that? 10/6, which is 5/3? It's greater than 1. I was waiting for somebody to say, so no solution?
Yeah.
Okay, next one. Now that one you find directly off the chart. At 180? Okay, you guys good? And it's an axis, so you don't place it in a quadrant. When you get one on the axis, you're finished. Okay. Any more? Everybody follow what we're doing on test tomorrow? Okay, make sure you know your 8 identities when you come into class.